All right, let's look at a second example. All right, so we're going to factor this long polynomial again. Okay, but let's use the information that we're given here. We know that x minus 5 is a factor of this polynomial. Right? We're going to try to use that to factor this. Right? The big thing you need to get from this is what that first sentence really means. What does this tell us when it tells us that x minus 5 is a factor of this? Right? It tells us that x minus 5 times something, right, would be equal to this. Right? And so the first factoring step would be x minus 5 times something times some other factor is going to get us back to this polynomial. Right? How would we figure this out? Right? We would use division. Right? I'd like you to go ahead and do that right now. Go ahead and show your work and do the division to figure out what this would be. All right, welcome back. To save time in this video, I'm not actually going to do the division. Right? But what you should have done was this: x to the fourth minus 3x cubed minus 13x squared plus 9x plus 30. Right? And if you divide that by x minus 5, what you should end up with is this. You should end up with x cubed plus 2x squared minus 3x minus 6. Right? And so what that tells us is that the first factoring step would be this: x minus 5 times x cubed plus 2x squared minus 3x minus 6. Right? These two things multiplied would get us back to this. Okay? All right, let's keep going. All right? This is not quite done being factored. Right? This can be factored some more. Right? Take a look and think about if you could factor anything else. All right, and you should recognize how to factor this. All right? Please go ahead and pause and finish factoring. All right, let's see what you did. This you can factor by grouping. So let's go ahead and factor. X minus 5 stays the same. And then inside here, this would be x squared times x plus 2 minus 3 times x plus 2. So this was going to get me x squared minus 3 times x plus 2 times x minus 5. All right, and that there is your answer. All right, one last problem here. All right, let's read this. It says, consider the function f of x is equal to x cubed minus 19x plus 30. It tells us that one of its zeros is 3. And our job is to find all of the zeros of f of x. All right, so first of all, let's make sure we understand what this term means, right? When we find zeros, what does that mean, right? Zeros are the input values that give us an output of 0, right? So right away, we know that our output, f of x, has to be 0. And we have to figure out what x values will make this true, right? So we can go ahead and start by setting f of x equal to 0, right? So we know 0 is equal to x cubed minus 19x plus 30. Right? And we're going to try to factor this and find the solutions. Right? Now you might think that this could be done by magic x. Right? So let's think about that. Negative 19x on the bottom, and then 30x cubed on the top. Right? But if you try this, it's not going to work. Right? There's no combination here that'll work. Right? And even if you just look at the x's, right? These would have to be x's, right, to add up to be something with an x. But an x times x will not give you x cubed, right? So magic x doesn't work in this case. So we got to figure out some other way to do this, some other way to factor this. Well, luckily, look at this sentence. It tells us that one of the zeros is 3. Let's think about what that means. If we know that one of the zeros is 3, that tells us a little bit about how this factors. If we know that one of the zeros is 3, let's think about that. What would be inside here? If one of the zeros is 3, then this factor would have to be x minus 3. Right? Because if we were to go to the end and use zero product property, we would get x minus 3 is equal to 0, we'd solve for x and get 3. So this would have to be x minus 3. right? But do we know what this would be? The answer is not yet. How do we figure this out? We're going to use division. Okay, I'd like you to go ahead and pause and do the division to figure out what would be in here. All right, please pause and do that. All right, I'm not going to show all the division. You guys should be pretty good at that by this point. But what you should have done is you should have divided x cubed plus 0x squared minus 19x plus 30 and divided that by x minus 3. When you do that, you should end up with x squared plus 3x minus 10. Right? So that means x minus 3 times x squared plus 3x minus 10. That's the factorization. Right? And that puts us in a lot better position. Let me rewrite this down here. So we have 0 equals x minus 3 times x squared plus 3x minus 10. Right? And remember, we're trying to find our zeros. All right. Can we factor this some more? The answer is yes, we can. I'd like you to go ahead and do that. Please pause, factor it, and find your zeros. All right. Let's check your work. Okay, you should have recognized that this could be factored with the magic x. Right? So if I have 3x down here, and it would be negative 10x squared on top. Right? The factors that work here would be 5x and negative 2x, because these two things multiply to get negative 10x squared and add up to be 3x. Right? So let's go ahead and factor this. So we have x minus 3, that doesn't change. This is going to be x squared plus 5x minus 2x minus 10. And then if we factor this, this is going to be x times x plus 5 minus 2 times x plus 5. Right, the x minus 3 is going to stay the same. So we end up with 0 is equal to x minus 3 times x minus 2 times x plus 5. Right, almost done. Let's find the zeros. If we use the zero product property, we know that either x minus 3 has to be equal to 0, or x minus 2 has to be equal to 0, or x plus 5 has to be equal to 0. So our zeros would be as follows. We'd get 3, we'd get positive 2, and we'd get negative 5. So here would be our three zeros, 3, 2, negative 5.